Hi, today we are looking at normal distribution. We'll also look at how the standard deviation that we calculated in the last section applies to normal distribution. So we'll start with some definitions. A normal curve is a symmetrical curve that represents a normal distribution. This is also often referred to as a bell curve. A normal distribution is when we have data that, when graphed by frequency, results in a symmetric distribution about the mean, which creates our normal curve. Now, this bell curve or normal curve looks something like this. So in the center of it, where our highest point is where our mean is. And then we have marked increments as we go up by 1 standard deviation, 2 standard deviations, 3 standard deviations, and downward -1, -2, -3. So what this essentially means, if we put it into some sort of context you may be more familiar with, is if, let's say, if class had a test, let's say if our class average was, let's say, 60%, and let's say their standard deviation was equal to, let's say, 5%. If we're going up by 1 standard deviation, that would mean that this here would be 65%. This here would be 70%. This here would be 75%. So each standard deviation is equal to that value we calculated for standard deviations. So it also works going downward. So if our mean was 60 and we have a standard deviation of 5%, this would be 55%, 50%, 45%. So next we'll look at how much of the data should normally be in each of these deviations if it's normally distributed. Okay, so properties of a normal distribution. So every curve has a mean, which is represented by mu, or we can use the x with a line over it, and a standard deviation, this. The area under a normal curve between A and B equals the proportion of the data between A and B. So for example, if we have, say, a curve, say it looks something like that, and let's say A is here and B is here, this area here represents what percentage of the data is between these two. So if we go back to that previous example of using it for test scores, let's say this is 55%, this is 80% score, the area here would represent how many students scored between 55 and 80%. Now this brings us to what's known as the 68, 95, 99 rule. Okay, so with this rule, so if we have our mean here and 1 standard deviation above and 1 standard deviation below, this total area in here represents 68% of the data. Now, with the second part, 95% is within 2 standard deviations of our mean. So if our mean is here, We have one standard deviation there, two standard deviations here, negative. And we have -2 standard deviations here. Then this total area represents 95% of the data between -2 and +2 standard deviations. Lastly, within 3 standard deviations, we have 99.7% of the data. Now we can utilize the 68, 95, 99.7 rule to figure out how much data is in each one of these sections. So we know that there's 68% here. Now that's being split into 2 separate sections. So what we can do is go 68, divide by 2, and that gives us 34%, which is how much is in each of these sections. Now we know that it's 95 between 2 standard deviations. So what we can do is we can go 95 minus 68. That'll give us how much is here and here. And that gives us 27% is between these two. We will divide that by 2. So that gives us 13.5% of the data is here and here. So 13.5% in this section and 13.5% in this section here. Next, we know that essentially 3 standard deviations is 99.7% of the data. So we can go 99.7 minus 95 to figure out how much is here and here. So that gives us 4.7. We'll divide that by 2. So that gives us 2.35% of the data. So we have 2.35% in this section, 2.35% in this section. All that's left is beyond these. So if we have 99, or the whole thing is 100 minus 99.7 gives us 0.3. We'll divide that by 2. So 0.15% is here and 0.15% is here. Okay, so we'll do an example for the population of a Canadian high school. Students Suppose that the number of hours of TV watched per week is normally distributed with a mean of 20 hours and a standard deviation of 4 hours. We want to sketch a normal curve to show the distribution of TV hours per week and mark the values on the horizontal axis that are 1, 2, and 3 standard deviations from our mean. Okay, so we'll start by drawing out a bell curve. Okay, so our mean is in the center. Then we have 1 standard deviation, 2 standard deviations, and 3 standard deviations. We'll have the same going in the opposite direction, so -1 standard deviation, -2 standard deviations, and -3 standard deviations. Now we will label that with information that we are given. So we were told that our mean was 20 hours, so it's going to go in the center. And our standard deviation was 4. So that means that 1 standard deviation over would be 20 plus 4, so it'd be 24. Another over, we'll add another 4, so that's 28. Add another 4, so that's 32. And it works going the other way too, so 20 minus 4 is 16. 16 minus 4 is 12. 12 minus 4 is 8. Okay, so we have done part A. We'll look at part B on the next slide. Okay, so approximately what percent of students watch between 16 and 24 hours, 12 and 28 hours, 8 and 32 hours, more than 20 hours, more than 28 hours, fewer than 24 hours. So we'll fill this in with the percentages that we had from here. So essentially we know that this is 0.15%, this is 13.5%. Oops, I did that on too early. That one is one more over because we had 0.15, 2.35. 13.5%, 34%, 34%, 13.5%, 2.35%, and 0.15%. Okay, so now we'll look at these questions again. So between 16 and 24 hours. So between 16 and 24 hours, so that'd be from here to here, so that would be 34% and 34%. So that'd be 34 plus 34. So that gives us 68%. Now between 12 and 28 hours. So that's from here to here. So that's 2 standard deviations from either side. So we should know that 2 standard deviations either side should be 95%. We could also, if we wanted, add these up, and this plus this plus this plus this should give us at 95%. Now 8 and 32 hours. So that's 3 standard deviations either side. So we should know that that is 99.7%. We can also add them up to get the same thing. Now we have more than 20 hours. So that would be from our mean this way. So automatically, if you're in the middle and measuring everything to one side of it, that's 50%. Now more than 28 hours would be from here upwards. That's 2.35 plus 0.15. So that's 2.5%. Fewer than 24 hours would be everything from here this way. So we'll have to add all these up. So that's 34 plus 34 plus 13.5 plus 2.35 plus 0.15. And we should end up with 84%.